Lesson 9.5, Graphing Other Trigonometric Functions. Our essential question, how do you explore characteristics of and graph tangent and cotangent functions? There are 3 graphs left on the page for independent practice. Let's go ahead and take a closer look at those. We're being asked to graph one period of tangent. So here is my y and here is my x. Tangent does not get amplitude. So we're going to start by just identifying my a, which is a 3, and my b, which is a 2. And from here, we just start by graphing our period. Period is pi all over 2 times the absolute value of b, and b is a 2. So it's pi all over 2 times the absolute value of 2, which simplifies down to pi fourths. So my period is pi fourths. I know that my intercept is always at the coordinate point 0, 0. And from there, I'm then supposed to find my asymptotes. There are 2 equations for asymptotes. Here is equation number 1, where my b is a 2. So it's 2 times the absolute value of 2, which is pi fourths. Equation number 2 is the negative of that. So my second asymptote is at negative pi fourths. And now we just need to find what our halfway points are so that we could figure out what the other graph is. The halfway points have 2 points, and they are formulas. So here's formula 1. And here is formula 2. My b is 2, my a is 3. So here are my 2 halfway points. So let's go ahead and graph these. I need to scale my x-axis. My x-axis needs to go from pi fourths to negative pi fourths. So we're going to do pi fourths, pi halves, pi fourths, pi halves. And my y's need to make sure they at least go to 3. So we're going to scale these by 1s. All right, where are my asymptotes? I know I have an asymptote at pi fourths right here. I have another asymptote at negative pi fourths. That was negative pi fourths. I just forgot my negatives. Positive pi fourths would have been just right here. So here is my first period. I know my x-intercept is going to be right here at the coordinate point 0, 0. Now I need my halfway points, which tells me halfway between here, where am I going? And halfway between here, where am I going? So pi 8's 3, pi 8's 3, negative pi 8's negative 3. So negative pi 8's negative 3. So here is this tangent function. And if you needed to replicate this to show more than one period, so here's your asymptote. That's going to be the same as this asymptote. So 2 away from the asymptote was an intercept. So 2 away from the asymptote is going to be the next intercept. I see that from here, you went over 1, up 3. So over 1, up 3. From here, over 1, down 3. So over 1, down 3. So here is the other tangent line. Well, what if we did this side? So 2 squares, intercept. 2 squares, there's your next intercept. You said over 1, up 3. So over 1, up 3. Over 1, down 3. Here's your other tangent if you were asked to graph more than one period. They are exactly the same, repeated every section of negative pi fourths to pi fourths. Now he's going to figure out what our transformation is. Your a was 3. A does vertical. So this is a vertical stretch. And why is it a vertical stretch? It's because it's bigger than 1. So this is vertical stretch by a factor of 3. B is 2. B always tells us our horizontal. And this is going to be a horizontal shrink. Why is this a horizontal shrink? It's because you're supposed to take the reciprocal to do your factor. So this is actually going to be 1 over 2. Our next problem. We're being asked to graph one period, but we need an XY axis. So let's graph our XY axis. We don't know how to scale it yet because we've got to find the information. Tangent does not have amplitude, so we're not going to do amplitude. But I do need to find my A, which is the 1/4, and I do need to find my B, which is a pi fourths. From here, I do need to find my period. Period is the equation pi all over 2 times the absolute value of B. So it's pi times pi all over 2 times the absolute value of B would have been a pi fourths. So simplifying this, I would have gotten the answer of 2. So my period is every 2. I know that my x-intercept is always at the coordinate point 0, 0. So now I just need to find my asymptotes. There are two equations for asymptotes. Equation number 1 is x equals pi all over 2 times the absolute value b. The second one is the negative of that. So my first asymptote is a positive 2. My second asymptote is a negative 2. So let's go ahead and graph these. So 1, 2, negative 1, negative 2. My asymptotes are at negative 2 and positive 2. Those are my asymptotes. I know where my x-intercept is. My x-intercept is right here at 0, 0. So here's my x-intercept. Now I just need to figure out halfway here, where's my other point? And halfway here, where's my other point? So I need my halfway points. And those are two equations. So here's equation number 1, and here's equation number 2. B is pi fourths, A is 1/4. So this is 1/4, which meant this was negative 1, negative 1/4. So I need to scale my y-axis. So I'm going to scale my y-axis by skip counting. So 1/4 would have been right here. Negative 1, negative 1/4 would have been right here. So tangent, curves, and then goes. Last, we just need to do our transformations. A, which is 1/4, and B, which is pi fourths. A is our vertical, and because this is smaller than 1, we're a vertical shrink. So this is a vertical shrink by factor of 1/4. This is going to be a horizontal, and we're supposed to reciprocal this, and if you reciprocal this, you're bigger than 1. So this is actually going to be a stretch. So this is a horizontal stretch by factor of 4 all over pi. Our last one. We're being asked to graph just one period of this tangent. So here is my y and here is my x. Tangents do not have amplitude, so we're not going to find amplitude, but my b is 2. So this is going to help me find my period, which is pi all over 2 times the absolute value of b, and b is 2. So this simplifies to pi over 4. I do know that my intercept is always the coordinate point 0, 0. And now I need to find my asymptotes. There are two equations for asymptotes. This is equation number 1, and this is equation number 2. So we have pi fourths as asymptote 1, and negative pi fourths as asymptote 2. Now we just need to find our halfway points. So there are two equations. This is equation number 1, and this is equation number 2, where b is 2 and a is 2. Point 1, point 2. So now we just need to scale so we can graph. So I'm going to scale my y-axis so I can see a pi fourths and then a pi halves. And my y-axis, I'm going to scale by 1s. All right, our asymptotes. We have an asymptote at pi fourths, so here's pi fourths. And I have an asymptote at negative pi fourths, so here is negative pi fourths. My intercept is at the coordinate point 0, 0, so here's my coordinate point 0, 0. Now halfway between the intercept and the asymptote is going to be first halfway point. So here's the first one. The other halfway will be the other direction, so here's the other one. So here's my one period of tangent. Now what if you needed to make sure you could graph the other one? 2 over from the asymptote will always be your intercept. So 2 over from the asymptote, intercept. 2 over from the asymptote, intercept. So here are my other intercepts if I needed to graph more than one period. I was always over 1, up 2, or over 1, down 2. So over 1, up 2, over 1, down 2. Over 1, up 2, over 1, down 2. So here are my other tangent functions if I needed to graph more tangent functions. Our last part is asking us about our transformations. A is 2, B is also 2. A tells us about our vertical, and since that is bigger than 1, this is going to be a vertical stretch, and it's vertical stretch by a factor of 2. B is always our horizontal, and you're supposed to reciprocal this. So it's not 2, it's 1/2, and that's smaller than 1, so we are shrinking. So we're shrinking by a factor of 1/2.